We generally treat human motivation as a simple additive equation. If an agent has an internal desire to complete a task, and we add an external reward, like money or status, we expect the combination to generate greater velocity. However, decades of behavioral data have revealed a persistent paradox in this math. When an external incentive is introduced to an internally driven system, momentum stalls. In many cases, the system collapses. Adding a tangible reward to a previously enjoyable task causes a systemic failure in the person's baseline drive. To build more effective systems for our work and our personal goals, we have to move past these additive assumptions. We need to rebuild our understanding of human action from its basic mechanical components. Every human endeavor begins with two fundamental parts, an agent and an action. For that agent to move toward the action, there must be a vector of force, a specific driver that compels them forward. Historically, we have treated this driving force as a uniform type of energy. If the agent slows down, we simply assume we need more pressure or a larger incentive to restart the motion. But research suggests there are two distinct, structurally incompatible engines powering human behavior. Because of their differing architectures, they cannot run simultaneously. Identifying which of these two engines is currently powering your behavior provides a clearer roadmap for managing your energy and addressing the structural causes of burnout. This diagram illustrates the first engine, which uses an outside-in architecture. Here, the agent performs an action solely to reach a separate third node, such as a paycheck, a promotion, or the avoidance of a penalty. In this configuration, the action itself is essentially a toll. It is a cost the agent pays in order to extract a specific reward from the environment. This creates a precarious dependency. The agent's drive is entirely reliant on the environment's ability to consistently provide and maintain that external reward. Now, consider the inside-out engine. In this model, the separate reward node is gone because it has been merged completely into the action itself. The driving vector originates from within the agent. For an inside-out system, the execution of the action is the outcome. There is no external extraction required and no secondary toll to pay. These two engines utilize energy in different ways. While the first engine constantly depletes the agent's internal reserves, the second engine is self-fueling, generating momentum through the act of execution. Relying on an outside-in engine means your motivation is always subject to the stability and whims of your external environment. We can see the moment these two architectures conflict in foundational behavioral studies from the 1970s. Researchers observed subjects who already enjoyed a specific puzzle and began offering them tangible, performance-contingent rewards for completing it. This chart shows the results. When the rewards were eventually removed, the subject's voluntary engagement didn't just return to its original level, it plummeted into a deep trough. The subjects lost interest in the very task they had previously pursued for fun. This phenomenon is known as the undermining effect. It occurs because the brain actively tracks the perceived origin of its own actions. When an external reward is introduced to an inside-out system, the brain shifts the perceived origin of the work from the self to the environment. The driving vector physically detaches from the agent and snaps to the external node. External rewards can act like a virus, overriding the agent's internal programming and making their future drive dependent on external validation. This creates a specific design challenge. How do we build a behavioral engine that is resistant to these external overwrites? Self-determination theory suggests we need three structural pillars. The first is self-direction. The agent must perceive the action as uncoerced and entirely volitional. The second pillar is capacity. The action must consistently stretch the agent's current skill set against an optimal, friction-inducing challenge. The third is connection. The action must integrate into a broader system of utility or community that extends beyond the individual. These three supports insulate the brain's tracking mechanism. They keep the perceived origin of action internal, preventing the environment from seizing control of the engine. Integrating these three pillars into our lives provides the structural foundation for a drive that can sustain itself regardless of external pressure. Modern labs are currently mapping these neurobiological circuits, but this high-performance operating state was documented over 2,000 years ago in the Roman Forum. The Stoic philosophers relied on the dichotomy of control. This principle requires a ruthless separation between volatile external events and a person's stable internal responses. To the Stoics, virtue was not a rigid moral posture, but a deliberate commitment to an inside-out engine. Marcus Aurelius and his peers focused on excellence as its own reward, independent of fame or fortune. This framework demands that we sever the psychological link between our effort and the environmental outcome. The quality of the execution becomes the only metric that matters. What the ancients described as virtue is the same anti-fragile, closed-loop architecture that modern psychologists call intrinsic motivation. The contrast is clear. The outside-in system is a frantic, exhausting chase after targets that constantly move, appear, and disappear based on external whims. By contrast, the inside-out system moves steadily forward, entirely indifferent to the chaotic external variables passing by in the periphery. Terms like intrinsic motivation, virtue, and the dopaminergic seeking system are different dialects for the same optimized state. The seeking system is a neural circuit that drives our innate urge to explore and master our environment for information rather than external prizes. This mechanical perspective removes the mystical ambiguity often associated with finding one's purpose. We achieve purpose through the specific, intentional alignment of our motivational vectors toward work that we value for its own sake. Developing this engine requires a daily decision to shift the origin of your actions from the volatile external world to your own stable internal values. When the execution of the task itself provides the ultimate reward, the human system no longer requires external fuel to continue its work. True autonomy and anti-fragility are only realized when our internal engine becomes a completely renewable, self-sustaining force.